finding cosecant theta and tangent theta. So these tasks, what we're going to be using is we're going to be using the Pythagorean Theorem Identities rather than just doing it the way that we'd been doing it earlier, drawing the triangle and using a squared plus b squared. So notice the three theorems down here: sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, cotangent squared plus 1 equals cosecant squared. And you might want to ask yourself, well, which one should we use? And you know, probably either this one would work or this one would work. And the reason I say that is because there's that cosecant squared. And the other theorem, the other identity that we know is that we know that sine theta is the exact same thing as 1 over cosecant theta. So cosecant is going to be the flip of that. And for this video and for this example, I went ahead and used this one since we more commonly use the first Pythagorean theorem. I wanted to go ahead and use this one. The other thing that I want you to pay attention, look at the information they gave us. They gave us that sine is positive, secant being less than 0 is negative. And remember the graph that I wanted you all to memorize is that this tells us in which quadrant the trig functions are positive. In first quadrant, all of them are. In second quadrant, sine and its inverse, cosecant. Third quadrant, its tangent and its inverse, they're positive. In fourth quadrant, it's cosine and secant. So we know that because this is positive and secant is negative, sine is positive here and here, but everything's positive. So we know we're going to be in that second quadrant, which means tangent is going to be negative. All right, cosecant will be positive, and tangent is going to be negative. All right, let's go ahead and get started. So I went ahead and set up the Pythagorean theorem. Cotangent squared plus 1 equals cosecant squared theta. And remember, cosecant is the flip of this. So cosecant theta is equal to 9 over 5. So we'll plug that into the parentheses. And notice what I did first. I went ahead and subtracted 1 from both sides before I start punching in numbers. And then look at what I did. Cotangent squared is equal to, well, 9 over 5 squared is 81 over 25. 1 we would just rewrite as 25 over 25 since they share the same denominator. And then when you subtract that, 81 subtract 25 is 56. So now we know that cotangent squared is equal to 56 over 25. Well, cotangent squared is the inverse of tangent squared. So I'm just going to flip that. And look at what I did. I flipped this because remember cotangent is the same, theta is the same as 1 over tangent. So I can flip that. Tangent squared, we just ended up flipping those two things. And now we're going to take the square root of both sides. So this is going to be 5, positive or negative 5, over, well, square root of 56, I'm going to write that as 4 times 14. So I'm going to pull out a positive or negative 2. So, and I think I may have already done that. I'm going to bring this down. Move those all out of the way. Wow, I needed to. Okay, so look at what happened. We took the square root of 25, positive or negative 5, over 2 root 14. We can't have a root 14 in the denominator, so we multiply top and bottom by root 14. So what we're left with, tangent theta is equal to positive or negative 5 root 14 over 28, because root 14 times root 14 is 14, times 2 is 28. But look at, we're talking about the second quadrant. The second quadrant's negative. So tangent is equal to the negative 5 root 14 over 28. And cosecant, we had already solved earlier because it's just the inverse of the sine. There you have it. And you could have just as easily used the first Pythagorean theorem. So, all right, that's it for this video.